Good day, students! Today we're going to tackle Module 3, which is all about ellipse. Ellipse is formed when a plane and a double right circular cone intersects and the plane is not parallel to any of the generators. By definition, ellipse is a set of all coplanar points wherein the sum of its distance from two fixed points is constant. The fixed points of the ellipse are called foci. Let's proceed to some terminologies that we will encounter throughout this topic. Suppose we have this graph of ellipse and identify its parts. First is the center. It is the point of intersection of the major and minor axes. It is also the midpoint of foci, vertices, and co-vertices. Next is the focus, or the foci, or f sub 1 and f sub 2. These are the fixed points of an ellipse. Then we have latus rectum. Latus rectum are the segments that passes through focus and also perpendicular to the major axis of an ellipse. Then we have the directrix. Directrix are the lines outside the ellipse that is also parallel to minor axis. Then we have the major axis. Major axis is the longer axis that have endpoints called vertices. Here are the vertices. This axis also contains the foci, as you can see on the graph. Last is the minor axis. Minor axis is the shorter axis that have the endpoints called co-vertices. Here are the co-vertices. And that are the terminologies that we will be encountering throughout this topic. These are the summary of different cases of ellipse. There are 4 cases of ellipse and I want you to familiarize it, for this will help you determine the standard, general equation, and the graph of ellipse. Here, the number 1 and number 2, next is the number 3 and number 4. And these are the standard equations of ellipse. If the center is at the origin and the principal or major axis is horizontal, then the general form to use is ax squared plus cy squared plus f is equal to 0, where a is less than c. And the standard form is x squared over a squared plus y squared over b squared is equal to 1, where a is greater than b. Next, if the center is still at the origin but the principal or major axis is vertical, then the general form should be ax squared plus cy squared plus f is equal to 0, where a is greater than c. And the standard form is x squared over b squared plus y squared over a squared is equal to 1, where a is greater than b. And if the center is at point hk and the principal or major axis is horizontal, the general form is ax squared plus cy squared plus dx plus ey plus f is equal to 0, where a is less than c. And the standard form is quantity x minus h squared over a squared plus quantity y minus k squared over b squared is equal to 1, where a is greater than b. Last, if the center is at hk but the principal or major axis is vertical, the general form is ax squared plus cy squared plus dx plus ey plus f is equal to 0, where a is greater than c. And the standard form is quantity x minus h squared over b squared plus quantity y minus k squared over a squared is equal to 1, where a is greater than b. Let's proceed to some examples. First, we're going to determine the standard equation and graph of ellipse. Example number 1, with given vertices at 0, 5 and 0, -5 and the length of minor axis, which is 4 units. So if we're going to plot the given vertices and notice that it has same x values, we know that this ellipse has a vertical major axis. You may see summary table case number 2 to guide you in this example. Next, we're going to get or solve for the center by using midpoint formula to the given vertices. So we can say that x sub 1 is 0, y sub 1 is 5, x sub 2 is 0, and y sub 2 is negative 5. So by substitution, we'll have c is equal to 0 plus 0 all over 2, comma 5 plus negative 5 all over 2. Simplify, we'll have a center at 0, comma 0. Next is we're going to solve for the length of A. We know that vertices are the endpoints of major axis. So by the given vertices, the length of vertex 1 to vertex 2 is the total length of major axis, which is 10 units, if you're going to count it. So we're going to let major axis is equal to 10. And in order to know the length of A, we will use the formula 2A is equal to major axis. So we'll have 2A is equal to 10. So using multiplication property of equality, we'll have 1/2 multiplied by 2A is equal to 10 multiplied by 1/2. Simplify, we'll have the length of A, which is 5. Next is the length of B. So we will let the minor axis is equal to 4. So it is from the given. Using the formula from the summary table case number 2, we'll have 2b is equal to minor axis. So 2b is equal to 4. Using multiplication property of equality, we'll have 1/2 times 2b is equal to 4 times 1/2. Simplify, we'll have the length of b, which is 2. Then we'll also solve for the length of C for us to easily complete the points needed to graph this example of ellipse. Since we already solved the value of A and B, we're just going to substitute it to the formula from the summary table case number 2, which is C is equal to square root of A squared minus B squared. So substitute the value of A and B, will have C is equal to square root of 5 squared minus 2 squared. So simplify 5 squared and 2 squared, will have C is equal to square root of 25 minus 4. Then simplify, we'll have C is equal to square root of 21. Then we will get the square root of 21, and we will be having the approximate length of C, which is 4.50. Now, let's get the points of co-vertices. From the summary table case number 2, we'll have co-vertex 1 at B, 0. So we're just going to substitute the length of B, which is 2. We'll have co-vertex 1 at point 2, 0. Next is the co-vertex 2, which is at negative B, 0. Substitute B, will have co-vertex 2 at negative 2, 0. Next is the foci. So from the summary table, case number 2, we'll have focus 1, which is at 0, C. So substitute the value of length of C, will have the focus 1 at 0, 4.58. Same with focus number 2 or focus 2 at 0, negative C. Substitute the value of length of C, we have focus 2 at 0, negative 4.58. Let's proceed in getting the standard form. Since the center is at the origin, we're going to use the formula x squared over b squared plus y squared over a squared is equal to 1. So we're just going to substitute the value of A and B. We will have x squared over 2 squared plus y squared over 5 squared is equal to 1. Simplify, we'll have the standard form for this example, which is x squared over 4 plus y squared over 25 is equal to 1. Let's graph the ellipse using the points we got. First is the center, which is at the origin, or 0, 0. Then Since the vertices are already given, leave it as it is. But as you can notice, I colored the length of A same with the color of the points of vertices because length of A will determine the distance of the vertices away from the center. Since A is equal to 5, if you will count 5 units going up, we'll get to the point of vertex 1. And 5 units going down, we'll get to the point of vertex 2. Same with the points of co-vertices. Since B is equal to 2 units, if you're going to observe, if you move 2 units to the right, starting from the center, we'll arrive at the point where co-vertex 1 is located, which is at 2, 0. And if you move 2 units to the left, starting from the center, we'll have co-vertex 2, which is at -2, 0. Let's do the same thing with the points of our foci. As you can see, the color of length of C is the same with our foci. It is because length of C will determine the distance of the foci away from the center. Since C is approximately equal to 4.58 units, if you will count 4.58 units going up, we'll get to the point of focus 1, which is at 0, 4.58. And if you will count 4.58 units going down, we'll get to the point where focus 2 is located, which is at 0, -4.58. Connect the points to see the graph of ellipse. So, since the graph of ellipse is vertical and the center is at the origin, you may see the summary table case number 2. We'll have the major axis at x is equal to 0 and a minor axis at y is equal to 0. And don't forget to name or label the graph by its standard form equation, which is x squared over 4 plus y squared over 25 is equal to 1. And that is the graph of this example. Let's try this example number 2 with given vertices at -7, 2 and 1, 2 and the length of minor axis, which is 4 units. Let's proceed to determining the general equation and graph of ellipse. Example number 1, with given quantity x minus 2 squared plus y squared over 16 is equal to 1. As you can see, this example has a vertical major axis since A is below y. You may see summary table case number 4 for this example. So the first thing we need to do is determine the center. Center is at h, k. So from the given, we'll have a center at 2, which is the h, and k, which is 0, since there is no k value in the given. Next, we're going to solve for the lengths of A, B, and C. As you can see, the value of a squared from the given is 16. So we let a squared is equal to 16. And in order to get the length of a, we're just going to get the square root of 16 and have the length of a, which is 4 units. Same with the length of b. So from the given, the value of b squared is equal to 1. So we let b squared is equal to 1 since it is not necessary to put 1 over quantity x minus 2 squared. In order to get the length of b, just get the square root of 1 and have the value of length of b, which is 1 unit. Now that we have the values for length of a and b, we can now determine the length of c by substitution. So we have c is equal to square root of a squared minus b squared. Then substitute the value of a and b. We have c is equal to square root of 4 squared minus 1 squared. Then simplify, we'll have c is equal to square root of 16 minus 1. And simplify again, we'll have c is equal to square root of 15. So the length of c is approximately equal to 3.87 units. Next is the vertices. So you may visit summary table case number 4 to guide you in determining the points of our vertices. So we will let h is equal to 2, k is equal to 0, and a is equal to 4. So vertex 1 is at h, k plus a. So substitute the values. We'll have 2, 0 plus 4. Then simplify, we'll have the vertex 1 at point 2, 4. Then vertex 2, which is at h, k minus a. Substitute the values. We'll have h at 2, k is 0, minus a is 4. Then simplify, we'll have vertex 2 at 2, negative 4. So same with co-vertices, you may visit summary table case number 4. So we're going to let h is equal to 2, k is equal to 0, and b is equal to 1. So co-vertex 1 is at h plus b, k. Substitute the values. We have 2 plus 1, 0. Simplify, co-vertex 1 is at 3, 0. Next is the co-vertex 2, which is at h minus b, k. So substitute the values. We have 2 minus 1, 0. Simplify, we'll have co-vertex 2 at 1, 0. Next is the foci. So we're going to let h is equal to 2, k is equal to 0, and c is approximately equal to 3.87. So focus 1 is at h, k plus c. So substitute the values. We have 2, 0 plus 3.87. Then simplify, we'll have focus 1 at 2, 3.87. Next is the focus 2, which is at h, k minus c. So substitute the values. We have 2, 0 minus 3.87. Then simplify, we'll have a focus 2 at 2, negative 3.87. Next is we're going to get the general form. So using the given, we're going to transform it to its general form. So given quantity x minus 2 squared plus y squared over 16 is equal to 1. So we're going to use multiplication property of equality by multiplying both sides by 16 over 1. We have 16 over 1 times quantity x minus 2 squared plus y squared over 16 is equal to 1 times 16 over 1. So we'll have 16 times x minus 2 squared over 1 plus 16y squared over 16 is equal to 16. Simplify, we'll have 16 times x minus 2 squared plus y squared is equal to 16. And then we're going to expand the value quantity x minus 2 squared and have 16 times x minus 2 times x minus 2 plus y squared is equal to 16. Then use FOIL method to it. We'll have 16 times x squared minus 4x plus 4 plus y squared is equal to 16. And then distribute 16 to x squared minus 4x plus 4. We'll have 16x squared minus 64x plus 64 plus y squared is equal to 16. So using addition property of equality to 16, we'll have 16x squared minus 64x plus 64 plus y squared minus 16 is equal to 0. So simplify, we'll have 16x squared plus y squared minus 64x plus 48 is equal to 0. And that is the general form of this example. Graphing this example. So center is at 2, 0. Vertex 1 is at 2, 4. Vertex 2 is at 2, negative 4. Then covertex 1 is at 3, 0. Covertex 2 is at 1, 0. Then focus 1 is at 2, 3.87. Then focus 2 is at 2, negative 3.87. So connect the points to see the graph of the ellipse. And then we're going to identify the major axis wherein x is equal to h. So since h is equal to 2, we have major of axis at x is equal to 2. Next is the minor axis where y is equal to k and our k is equal to 0. So minor axis is at y is equal to 0. And lastly, the name of the graph using the standard form, which is quantity x minus 2 squared plus y squared over 16 is equal to 1. Let's try this example number 2, which is x squared over 16 plus y squared over 4 is equal to 1. Done! Thank you for watching.